folks. I'm Kumar Mallikarjuna. You can refer to me as Kumar or Arjun, however you like during the presentation. And I work as a software engineer at Nirmata. It's been a tremendous year, a year and a half working in Kubernetes and cloud native. And I've worked with Kyverno project, and then I worked with Nutanix with one of their Kubernetes projects. And right now I'm back again at Nirmata, working with their platform team. So over to you, Anushka.
Thank you. So in this slide, I have tried to quickly summarize what we want to go through today in this quick session that we have. So we'll set the background straight, what we're talking about, that's pod security policies, pod security admission, and we'll talk about the limitations of pod security admission, and then quickly introduce Kyverno with a couple of demos. So let's get started. So policies, this is something that we have heard about in the Kubernetes environment here and there, back and forth. And truth be told, when I first started working on policies, I had no idea what policy meant for about a month. And I was like, okay, it's something. Policy basically means a guideline. Okay, I'll work along with that. Well, that is what it is. A policy in Kubernetes is to define what your end users can or cannot do. And the possible ways to ensure in which the clusters are in compliance. So policies will have things defined. We'll look at a couple of policies in a while. So that's a quick idea on what policies are. They are used to define what you can do and what you cannot do. So Kubernetes, it's a powerful tool, right? We have used it. It's enabled us with so many capabilities to do so much. Securing Kubernetes is extremely important. Policies can be used to control containers and clusters in multiple ways. You can have network policies, resource consumption and usage policies, volume, and most importantly, according to me, security policies. A policy-based approach to manage Kubernetes clusters really simplifies your work when you're trying to manage vulnerabilities and threats in clusters and containers. That's why policies have, really risen to the place they are right now, and policy management is something that we're talking about. So policy management is something that's in, and the CNCF ecosystem has a couple of tools that will help manage policies. Some of them to name are OPA Gatekeeper and Kyverno that we'll be discussing in a while. So I think it's important to understand that using policies is easy, and it helps you ensure that your Kubernetes cluster container is secure, it's in compliance with whatever rules and guidelines you have, and it follows the best practices. Now that we have, now that we've sort of heard about policies, policy management, OPA, Kyverno, let's talk about how security in Kubernetes is essential. Great, that's established. We need to secure our Kubernetes workloads. And Pod, as we know, is the smallest unit of execution in Kubernetes. So you can imagine that securing pods would be of utmost importance. It's crucial, really. So, of course, folks at CNCF realized that, and they came up with something called pod security policies. The abbreviation, the short form being PSPs. Now, PSPs are a cluster-level resource that will help, control security of your pods. So these came up in 1.3 version of Kubernetes as a beta feature and quickly grew because of its importance in our ecosystem. And you can see there's a timeline right here. 1.3, it came up as a beta feature. 1.6, it was available as default, and it grew really quickly. It was great. So pod security policy, it generally wanted to stop anything that is violating your policy. You don't want something to happen, and if you have a pod security policy in place, any resource violating that will be rejected. As simple as that. But there is a reason why by 1.16 we had public discussions on replacement of PSPs, right? So PSPs had its own issues. These issues, to list some of them, were that PSPs weren't intuitive. They weren't very easy to use. You need this sort of binding with users and services, and you need to remember it every time you have a new pod security policy. Also, introducing a pod security policy in an already functioning cluster is extremely difficult. Maybe some of you have faced this before. And another thing to note here is if you do inject some sort of pod security policy in a running cluster, it will not apply to the already existing pods. It will only apply to whatever new resources are to come. So that would just build you for some sort of misconfiguration later. And that's not an ideal situation, right? Finally, pod security policies were meant for pods. That, as important and crucial as that is, it doesn't solve most of our requirements. So, seeing this, we started talking about depreciation of pod security policies, and in 1.21, PSPs were depreciated, in fact, and it's scheduled for removal in 1.25. So, you have pod security policies that are being depreciated, they'll be removed, they are scheduled to be removed. This sort of created a vacuum in this space where you need security or something to ensure security in clusters and containers. So here, our Kubernetes auth special interest group came up with PSS and PSA. That stands for Pod Security Standards and Pod Security Admission. Let's talk about each for a minute. And let's start with pod security standards. So pod security standards were defined, these standards define three sorts of policies. So these policies were supposed to cover an entire range of security spectrum. So that's from privileged to restricted. The three policies that are defined, they are privileged, baseline, and restricted. So if we do have to talk about each of them quickly, privileged is, as the name suggests, it's unrestricted. It's very easy to go about. There are not any restriction levied where there'll be some sort of rejection to resources. This is great. This allows for greatest levels of access and would come to use when you want to log. Logging agents require this where they don't really want to be restricted. Next, following privileged, we have baseline. Baseline is minimally restricted. That is to say that there are some restrictions. You cannot be as free as you were when you were using a privileged pod security standard, but with some restrictions. Maybe you won't be able to access Linux capabilities and do something about them, but very minimal restrictions. Building on baseline, we have restricted pod security standard. Restricted pod security standard is the highest level of, restrictions where you are not allowed to do a lot of things. It's building on baseline, so that would mean there are some restrictions in baseline pod security standard. Adding on to that, there are some more in restricted. This is usually used in very security critical workloads, and right, it won't allow you to say run as root or as a root group. Now, PSA is something that Kubernetes auth special interest group did come up with, and Arjun will take over that. And over to you, Arjun.
Okay, so we discussed the problems with PSPs and how PSS were a simple solution to it, but how do you apply those solutions? That's where PSA comes in. So as the name suggests, it's pod security admission. So admission says we do something while we are admitting the pods. So let's say we have a pod definition file here, security context privilege true. That's a setting there. And I want to see if this satisfies the PSS or not. So I have three namespaces here. One is I don't know if you can see the font, but in namespace A, you have enforced policy for baseline. Then similarly for B, we have privileged, and second for restricted. Before I go into that, let's discuss what enforce, audit, and warn here mean. They're modes. So there are three modes in Kubernetes, mostly enforce, audit, and warn. So when you talk about enforcement, you say that if I have a pod that's incoming but it violates a PSS, that I want it to go through. So that when that happens, we stop that pod from being admitted, and therefore the name admission. So then the second thing is audit. Audit means that we do let the pod go in, but we make sure that it is logged inside the Kubernetes audit logs, and so that later on we can know if something has gone wrong. And warn is when, let's say, the user is admitting the pod, then itself we show them a warning that, hey, this went wrong, and these are the rules that were violated for the certain PSS, and that's why you should look into it. So how PSA is applied? Now, it's very simple to apply. we just use labels, pod labels, namespace labels. And why I say namespace labels? Because PSA has this restriction that it can only work at the namespace level. And that's one thing we'll address with Kyverno. How do you apply, let's say, a privileged PSS to a namespace? So like in namespace B, I have just set the label with the mode as enforce and level is privileged. And so that way, if I try to admit this policy, and as Anushka mentioned to you, that privilege have, they are very liberal PSS, and you have, you can admit almost anything into it, any pod, without much hassle. So namespace B does allow the privilege escalation here. However, namespace A, which is applying a baseline PSS, and namespace C, which is applying a restricted PSS, does not let it go in. Okay, so before that, before we go into the limitations, let me just show you a demo on how PSA works. So, okay, so I have these namespaces here right now, and in the default namespace, I'm going to admit a new pod, which is an Nginx pod. So as you can see, it has the latest image tag. And why I'm using this is because it's pretty simple to show you how PSS and PSA are effective. So let me admit this pod. Now this pod goes in because we don't have any PSS, any PSA labels applied right now. So what do I do if I want to apply PSA? So I have this namespace defined for you, which has the label, as we discussed, enforce restricted. So this is a restricted, is applying a restricted PSS, and therefore it should deny, as we saw in the image there. So let's make this namespace. Okay, so now I have this namespace created, and in that namespace, I'm going to admit the Nginx pod again. Okay, so what do you see here? We have the pods, Nginx is forbidden. So we get a warning and it's not allowed to go in. So you can see in the namespace, we don't have that pod, right? So with that, let's discuss the limitations of PSA. So PSA, as I mentioned to you earlier, works at a namespace level, and that itself is a big limitation. So and before that, as we discussed with PSP, they were highly complex to use. They were cumbersome and complex. So that's why PSA and PSS were an oversimplification, so that if users want to, let's say, apply their own policies, write their own policies, have security standards applied in certain scopes, then they can rely on other more like the outside that are in the community policy engines such as Kyverno and OPA Gatekeeper. So the restriction in scope, let's walk you through an example on that. So what do I mean by scope? We did talk about that PSA is applied at the namespace level, but a scope can be that I want to limit a certain PSS to only a certain, to my production pods. So production pods, let's say I label all of them with the label purpose prod, right? So this defines a scope. And how do we work on that scope? That's not possible with PSA, but we can do that with Kyverno or OPA. And secondly, they don't offer granular controls. By that, I mean that you have to rely only on the PSS. You cannot have your own policies. So as in the image earlier, I had privilege escalation set to false. So this was part of the 3 PSS we discussed, but we can't write a standalone policy for this with PSA right now. And on that note, let's talk about Kyverno. So Kyverno is a policy engine that was designed to be Kubernetes native. It was designed to be simple. You can write policies as YAML files, and the most important thing is that it runs pretty well, integrates pretty well, because it uses CRDs, custom resource definitions, as policies. And there are, so this diagram here, it's like you can use it while you are developing it, you can use it while the demo. It kind of sums up Kyverno for you. So you have a policy and there are certain rules and number of rules you can define in them, and you have match and exclude. Match and exclude, they are for matching the resources that you want to filter out or apply this policy to. So you can specify resource kind, resource names, labels, and so forth. So secondly, and then the most important thing about Kyverno, that it offers a four tuple, I should say, four tuple rules. So there are mutate rules, verify images rules, validation rules, and generate rules. So these rules are very, very important when it comes to having better control over Kubernetes. Why I say that is because you saw in PSA, we were just rejecting a resource or logging or showing a warning based on whether a policy is satisfied or not. So, but policies need not just be about the validation, they can be more than that. They can be about mutation. So let's say if I have an incoming deployment and I want to apply, let's say, a certain security context or a certain label or any relevant attribution to it, then that way we can use mutate policies. And then we come to generate policies, which is a very powerful feature in Kyverno. So if you have one resource incoming, you can actually generate another resource simultaneously based on its admission. So if I have a namespace, say, being created, and I want to ensure that every namespace, every new namespace that I admit, I also have a certain config map or a certain resource in it, then we can do that with generate rules. And then we come to verify images. So verify images is again a very powerful feature. So we are talking about security a lot nowadays, and verify images is just a way in Kyverno in which you can validate that your images are coming from an authentic source and they are good to use images, safe images. So, and with that we have PSA plus Kyverno. So how PSA and Kyverno can be integrated and how we can extend them finally. So we talked about scope, so we can have better filtering with Kyverno and we can integrate that with PSA. We can have centralized reporting with Kyverno. You can have policy reports, you can have policy violation events, policy applied events. And so you have events and reports to look to, and you have a good outlook on where your cluster is in terms of policies. Then you have fine-grained security configuration. As we saw, PSA does not, or PSA or PSS do not offer granular control. You can define your own policies with Kyverno, of course. And that way you can enforce security best practices. There are a lot of Kyverno policies that are easy to use. There are in the Kyverno.io, we have over 230 policies right now, with including the PSS. They have been documented, converted to Kyverno policies. So there are plethora of resources and best practices on Kyverno. And then one of the very important features, as I mentioned earlier, in PSA, we work during the admission. However, Kyverno can work during background scans as well, so using background scans. So background scans, they essentially mean that even though you have your pods in right now, even though you have your resources in, Kyverno can go through them and validate them and or apply some rules to them, even though they are not being admitted right now. On that note, okay, Anushka would walk you through a Kyverno demo. We'll talk about basics of Kyverno, and then you'll go through the examples of policies and see how easy to use Kyverno is. We'll talk about PSS with Kyverno, and finally I'll take you through PSA with Kyverno.
Yes, so Arjun did talk a lot about the resources that are available before we get into the demo. So Kyverno.io, that's the page where you can read a lot more about Kyverno, the policies. Right there you'll see documentation which will give you a quick, going through installation, going through a quick demo. And that's the policies that we were talking about right there. It's a lot of policies. I'll be demoing one of them right now, right here. So let's get into it. So since net was a little bit of constraint, we already have a cluster running. Like you can see. And I've already got my Kyverno in a namespace running as well. So that is a Kyverno instance running in my Kyverno namespace in my already running cluster. So let's start by looking at a Kyverno validate policy, right? Yeah.
No, that's
No, that's yours. Sorry.
demo to resource.
Okay. Great. So that is the policy I was talking about. So what we want to do here, I'll quickly tell that first. We want to disallow any image that has a latest tag to run in our cluster, right? So the policy is very simple, really. So like any YAML file that you would have, you have 4 fields: API version, kind, metadata, and spec that you will have to fill. And API version is set to Kyverno.io v1. Kind, this is a cluster policy. If you had a policy that was, say, a namespace specific policy, that would be replaced by a simple policy. In your metadata, you can see that the name of the policy is given as disallow latest tag. That just make it very explanatory. And you have some annotations ranging from title to description. This will help us when we are trying to diagnose what happened exactly. Finally, spec. So here we want to fill what exactly is it that we want to achieve. You can see the first field there is validation failure action. That can be set to either enforce or audit. Now, enforce would mean that, okay, if there's a resource that is going to violate my policy, stop, reject it right there. But if I had audit in place of enforce, that would simply just log that in your logs, and you could probably run through your logs to see what was violated or what happened when. That's something. And next field you see background. Arjun just mentioned background scans in Kyverno. So that is set to true here. That would mean if there are already existing resources that need to be checked, for violations, they will be checked as well in background scans. You can, of course, time your background scans to every hour, every day, or something like that. Now, here we come to rules. When we were going through the Kyverno slides, like Arjun mentioned, there is this certain format. In a policy, you have the rules section. There you have multiple rules. Here you can see there are 2, namely require image tag and validate image tag. In that you can match or exclude. In our case, we are matching to resources, say kinds. And again in that we have validate. So here we want to, essentially see. So if it's validate in this case, I'm validating my resources. That could might as well be mutate or generate or verify images. And here I'm trying to validate if there is a violation, the message that you see would appear. The pattern that it's supposed to check is also mentioned. In our case, it would just be all. So those are the 2 rules that we have here. Let's try running a pod with, was there an edge? Okay, yeah, let's try running a pod with the latest image. So that would be, is Nginx still running?
Yeah.
Yeah, okay.
Let's just delete that one.
Yeah, we have Nginx running from the previous demo, so let's quickly delete that. And sorry.
You missed the equals here.
Yeah. No.
Let me do that.
Oh, I'm sorry, that's really my bad. I didn't apply the policy. So let's probably remember that, Anushka, that you are supposed to apply a policy once you've written it. Let's quickly delete that policy, that pod again. It was in
Demo.
Now that we've applied, you see that a cluster policy is created to do its job. That would be disallow a pod with the latest tag. Thank God. So you see that you get an error from server message that validate.kyverno has rejected, denied the request. You see why exactly it was rejected here in the policy section. It is violating disallow latest tag policy, and you see the description printed here. So that's really easy, right? You get your resources blocked and you see exactly what happened and when and why. So with that, you know what a Kyverno policy is, how a validate policy would work, and how it will look. Let's maybe try to get your pod security standard best policies using Kyverno. So there is let's go to yes, so in Kyberno we have certain policies. You'll see in policies right here. Best practices. There are best practices policies, but that's not the one we're looking for right now. We are looking for pod security. And in pod security, you will see baseline and restricted. These are policies that are already there in the GitHub repository. Like I mentioned a while ago, in the pod security standards, baseline is with some minimal restrictions and restricted is with a lot of restrictions there. So let's quickly have a look. Okay. Control R. So that is your that is a command I'm using. I'm using customize build to get the policies that we just saw, baseline and restricted, and I'm applying them. So let's run this. Might take a couple of seconds. Yes, so here you'll see that all those policies that we just saw there in baseline and restricted are created in your cluster. They are, I think, about 14 of these. We will see all of these. Yes, so these are the policies in your cluster right now. You'll see that the action is set to audit to most of them and enforce to just one. Enforce is the one we just saw, disallow latest tag. We can, of course, change it, so I will change one of them. And let's look at right, this is the policy. This is the same policy where you want to disallow privilege escalation. So back when we had pod security policies, we still have it, but when we used to consider pod security policies, that allowed us to, set allow privilege escalation to true or false as the requirement may be. In this policy, what we're trying to do is disallow it in several contexts, like we'll see in the rules part of it. So right, in the patterns you can see in in containers, in init containers and other places, we will disallow, or rather allow privilege escalation is set to false. So that means I should not be able to run a resource as a root. So that's exactly what I'll try to do. Let's look at a resource. Let's look as a resource that is trying to run as root with my run as user set to 0. This pod should be rejected. So let's try to apply it. Note to self, stop doing the same thing again. Okay, let's delete the pod. And let's apply the policy. That's really my bad, I'm sorry. So, couple of seconds here. All right, so just fasten this process. I will apply the policy. I will try to run the pod, and it will reject it. We see that it's configured because it was already in our cluster as audit, so it should show get cpol. It should show disallow privilege escalation as enforce right there because we have configured it right now. And let's try to apply the YAML, and we'll see that it's denied like expected, and the reason it was denied was because we want to disallow privilege escalation. That is the policy that was being violated. Therefore, the resource rejected. That and one last demo over to you, Arjun.
Okay. Folks, so we talked about granularity here, but how I will show you how we can probably extend the PSA scope outside of namespace, maybe to multiple namespaces, or more like, let me just show you a mutation rule. So given right now we showed you the validation rules. So I have written a policy for you here. That's the PSA mutate policy, and what it would do is for any incoming namespaces, it would automatically apply this label, and therefore it would apply PSA automatically. So if I create, let's say, a namespace test1 right now, and I show you the okay, so you see PSA is not applied here, and so in that namespace I can admit virtually anything. So if I, however, apply this policy, on that note, let me delete the policies that are already there, so they don't hinder us, just in case. Okay, so now let's look at the policies. Okay, I am going to delete this policy as well. Okay, now we don't have any policies applied, and I'm just going to apply the policy, the mutation policy. So you see now we have the mutation policy, and now it's in ready state anytime soon. Okay, should be working though. So if I create my new namespace, let's say test2, and I show you the YAML, you can see the label is already applied, and so PSA should be working here. And but let's just, in case you don't believe me, let's just show you anyway. See, so PSA was automatically applied in this case, and that was our last demo, and thanks a lot, folks. You can learn more about Kivano on kivano.io, and we have plethora of policies as I showed you, and you can come on to our Slack channel and talk to us. We have monthly community meetings, weekly contributors meetings, so if you want to contribute, we'd look forward to that. And our Twitter handle is @Kivano.
We do have our personal Twitter handles on the second slide way back up, so don't feel shy to say hi or just talk about Kivano. PSA.
Thank you.
So thank you, folks. We have references listed, and I'm guessing these slides will be available. So please go to them. There are some amazing resources, some amazing videos and blogs. That's all from us. Thank you.
Thank you.
Hi, this is Sumit. So my first question is how this Kivano is different from OPA Gatekeeper?
So the first thing I can think of right now, off the top of my head, is the fact that you do not need to learn a new language.
You mean Rego, right?
Yes.
What I've highlighted to you, easy to write.
It's Kubernetes native, making it really simple, very intuitive. And yes, as far as I know, I've not used OPA, but you need to learn this language, Rego, and it's complicated, right? I think that would be one of the key differences that I can think of. Anything else?
All right.
Yeah.
And is there any playground available, just like, OPA Gatekeeper for that, for
Sorry?
Kivano? Is there any playground available? Where we can just test the Kivano policies and all. So just like OPA Gatekeeper provide a playground where we can simply check the Rego policies and all.
We don't have a playground right now, but as I showed you, it's like pretty simple to get it up and running. Hell, I can show you that Kivano can be up and running in one command, right? If you want.
Since it is very native, so you can really just try it in your already existing cluster. But
So this is all it takes to apply Kivano to your cluster.
Understood, understood.
yeah, there is a playground in Works, if I'm not wrong, and hopefully that'll be up to. So yeah.
Sure, sure. Thank you.
Anything else? Thank you for the question, though.
And on that note, another thing that Kivano right now has the largest library for policies available right now.
Yeah, hi guys,
Hi.
myself Aditya. I was going to extend that question only. What if I have already invested myself very heavily in OPA? Do I have a strong enough reason to go to Kivano? You just said about Rego rules, what I've already employed that, right?
Right.
So do you guys have anything that I
okay.
can think about migration and stuff?
Yeah, I get that migration would seem difficult, but to answer that question, I think the fact that you can generate resources, mutate resources, and even verify images, that's something new that's coming up. I think these are some things that you cannot do with OPA, correct me if I'm wrong.
I am not sure either.
Yes,
Can do it actually.
you can generate resources.
Actually, it's a very customized way of doing things.
Okay.
I understand that part, that Kyverno might have a good amount of libraries. That would be a very good advantage to it. But I just wanted to know from you guys as well that other than that, do we have anything that I go and invest myself and think about reasons that yes, it is going to be such a tool set that can.
So I see, I see Pratik right there, and he geared up to answer. So.
Yes. So one of the major difference you can see as compared to OPA is generate. Okay, you cannot generate with OPA, right? Either you have to write a very complex Rego logic or, right?
I have to write
so that's
the
not
Rego logic.
straightforward. Other than that, image verification is not straightforward in OPA. I think they just introduced in latest release or something like that, but it's not stable yet and all stuff. And PSA, right? So OPA doesn't have PSA. And then in Kubernetes, there is a new thing like called CEL, customized language for the custom resource CIDs, which can be integrated with Kyverno as well. We are working on that, so that's another great advantage of having Kyverno in a cluster, other than if you compare it with OPA.
Yeah. So I'll just add one more point to this. In addition to this being Kubernetes native and having generate capabilities, we have also seen. So there are some customers who have actually moved out of OPA, for specific use cases. So image verification being one of them, and they start with one use case and slowly they move on from multiple use cases they have already created. Also, they have seen performance benefits. So in some cases, the memory has been as low as 50% less compared to what OPA would be using, right? So those are some of the reasons, but there are a few more. For example, I don't know about OPA, but we are agnostic to Kubernetes distribution, so it works across AKS, EKS, GKE, OKE, OpenShift, Rancher. So whatever distributions you have, we work very seamlessly on it. We also have adapters for multiple other tools like Venafi, Vault, and so on, right? So those are some of the capabilities that essentially we have seen customers interested in. But yeah, if you have any specific use cases, we can talk about it.
Cool. Thank you.
Yeah, one more advantage, Kyverno has its reports, policy report system. So you can create critical events, alerts, and all those stuff as well, which is not there in other policy engines. Yes, everything is in documentation. Yeah, thank you.
Thank you, Pratik. Thank you, Ranjish. And yes, I think to end this, the note would be, for me, the selling point is the simplicity and how intuitive Kyverno is. With that, I think we'll be available later to chat about Kyverno and policies, pod security admission in general. Thank you.
Or anything in general.
Yeah.
To be honest.
Thank you, Anushka and Mallikarjuna. It was a great talk on pod security.
Just one more point, and I think you were asking about the playground, right? So there is a free trial version available. It's, I think, try.nirmata.io. So Nirmata is the parent company supporting Kyverno. So there you can try it out. It's a advanced version of Kyverno with the dashboards.